Plate tectonics, tectonic plates, how they differ. Let's talk about this in this new Fritzby video. Some of you are a little bit confused about what's the difference between plate tectonics and tectonic plates. Well, first of all, plate tectonics is a scientific theory that states the Earth's crust is separated into numerous plates that move over the asthenosphere. It also supports the continental drift theory of Alfred Wegener in 1915 that states that the continents nowadays were once united and became a supercontinent, and it was called Pangaea. It is noticeable nowadays that the continents will look like a jigsaw puzzle that fits together. On the other hand, tectonic plate, also known as lithospheric plate, is a massive, irregular shaped slab of solid rock generally composed of oceanic and continental lithosphere. So, to sum it all, plate tectonics is the theory of the movement of the plates, and the tectonic plates is the plates that plate tectonics theory referring to. How lithospheric plates move and why are they moving? Let's talk about this in this new Fritzby video. Lithospheric or tectonic plates move because of the Earth's internal heat, or somewhat called as asthenosphere thermal convection system. In asthenosphere, there is a convection current that moves in a circular motion, or looks like an endless roller coaster, I guess. So there is a continuous movement of the plates. There are also three gravitational forces that drives the plate's motion. First is viscous drag, second is ridge push, and the third one is the slab pull. And the movement of the plates that make up an Earth's crust is what we call tectonic shift. Furthermore, plates move at a rate of more or less 1 to 2 inches or 3 to 5 centimeters per year. Convergent, divergent, and transform plate boundaries. What are the differences? Let's talk about this in this new Fritzby video. There are three main types of plate boundaries. The first one is convergent boundaries, where two plates are colliding. Subduction zones occur when one or both of the tectonic plates are composed of oceanic crust. The denser plate is subducted under the less dense plate, and the plate being forced under is eventually melted or destroyed. Island arcs and oceanic trenches occur when both of the plates are made up of oceanic crust. Zones of active seafloor spreading can also occur behind the island arc, known as the back arc basins. And these are often associated with submarine volcanoes. Well, in that case, the denser oceanic plate is subducted, often forming a mountain ranges on the continent. Both continental crusts are too heavy to subduct, so a continent collision occurs. That creates especially large mountain ranges, and the most spectacular example of that is the Himalayas mountain. And now, let's talk about divergent boundaries, where two plates are moving apart. If two plates are moving apart, it creates space, and this space can also be filled with another crustal plate because of the molten magma beneath the Earth's crust that rises above, cools down, so it makes another plate. Divergent boundaries can form within the continents, but will eventually open up and become an ocean basins. Divergent boundaries within the continents initially produce rifts, which also produces rift valleys. The most active divergent plate boundaries are between oceanic plates, and are often called as mid-oceanic ridges. And now, the last type of plate boundaries is what we called transform boundaries, where the plates slide past each other. In transform boundaries, the relative motion of the plates is horizontal. They can occur underwater or on land, and the crust is neither created nor destroyed. Because of the friction, the plates cannot just simply glide past each other. Rather, the stress builds up in both plates, and when it exceeds to the thresholds of the rocks, the energy is released, causing earthquakes. That's all for today. Thank you so much for listening in the new Fritzby video.